Hi again, math friends. Today we're looking at section 8.7, solve one-step inequalities. Recall that our inequalities can use the greater than symbol, less than, greater than or equal to, or even the less than or equal to signs. You're going to see these in these equations, but remember they're called inequalities because they use these signs instead of an equal sign. Let's review something for just a moment here. X plus 3 equals 11. How would we solve for x? We would say, oh, there's both sides of the equation. Since I'm doing plus 3, the inverse operation of plus 3 would be to subtract 3. And we have to do that on both sides to keep the equation balanced. And then we're just left with x equals 8. What if this was an inequality, though? What if, for example, we said x plus 3 is greater than 11? Let's use the same steps. Just don't even think of this as an inequality right now. Think of this as an equal sign while you're working, if that helps. So we're going to draw a line down the middle. X plus 3, well, the opposite would be to subtract 3. So you would have x on your left side and 8 on your right side. Remember, this equal sign just drops straight down? This inequality also drops straight down. So now you have x is greater than 8. We'll try a couple more together, and then we'll try some where we have to also graph them. Let's look at m minus 5 is less than 12. Well, where's our inequality? There's our inequality sign. We have m minus 5. The inverse of minus 5 is to do plus 5. Remember, the minus 5 and plus 5, those become 0, so we just have m. And we also have 12 plus 5 is 17. This inequality sign will drop straight down. So our solution is m is less than 17. We can check that by trying some numbers that are less than 17. Let's try 10. 10 minus 5 is less than 12. Is that correct? 10 minus 5 is 5. Is 5 less than 12? Yeah, that checks out. That means that our inequality worked. If you'd like to try more numbers, you can. Let's try another example now. 2y is less than or equal to 28. Remember, when they're right next to each other, the number and the variable, that means you're multiplying. The inverse of multiplication is division. So let's divide both by 2. Those 2's divide out. You're just left with y. And 28 divided by 2 is 14. Your inequality sign drops straight down. So you have y is less than or equal to 14. Now we're going to put both things together. We're going to solve an inequality, and then we're going to graph it. In here we have c plus 17 is less than or equal to 20. Let's solve that just as we normally would. So instead of doing adding 17, we do subtract 17. And then we would get c is less than or equal to 3. Remember, we need to graph that now. C is less than or equal to 3. We know how to do that. Let's go to 3. Less than or equal to, that means a solid dot. And less than means we go to the left. Let's look at a couple more. Our first example up here on this side is z over 2 is greater than or equal to 10. Since we're dividing by 2, remember the inverse would be to multiply on both sides. These 2's divide out, and we have z. Drop down our inequality sign. Z is greater than or equal to 20. So let's find 20. Greater than or equal to, solid dot. Greater than goes to the right. Our last example here is r minus 3 is less than 27. To solve for r minus 3, let's do the inverse. Plus 3 to both sides. Then we'll have r is less than 30. Remember we have less than, we don't have less than or equal to, so let's find 30. Put an open dot on there. And less than, we need to go to the left. So make sure that you shade all the way to the left, and then always draw that arrow at the end. Alright, next we're going to look at this word problem to try to find out how do we write an inequality based on words. If Patrick makes $20, then he will have at least $45 to buy a new game. Write an inequality and graph the solution to show how much Patrick could have now. Let's think about this. If Patrick makes $20, so we don't know how much he has right now. So something about making $20, and our other piece of information here is at least 45. Think about the symbols and what symbol could mean at least. If he makes $20, so that seems like he's adding. So let's use a P. So let's use the letter P to show how much money Patrick has right now. Plus 20 would be at least. So it could be more, or it could be the exact amount. Is at least $45. First we have to solve this before we can graph it, and before we even draw our graph. So I would do minus 20. So we'll have P is greater than or equal to 25. How should we make our graph though? Since we know that we're dealing with the number 25, we should probably make our graph start at 25, or maybe we could put 25 in the middle. We can make it however we'd like to. I'm going to go by fives here. Now that the graph's been made, let's look at this. Negative 10. How could somebody have negative dollars? That could mean that they owe somebody money. So think about that. Negative numbers always come into play in real life situations. Let's look at our inequality and how do we graph it. P is greater than or equal to 25. What kind of dot are we going to use? Open or closed? Since we have that equal sign underneath, we're going to use a closed dot. Let's put it at 25. And P is greater than or equal to. So greater than would go to the right. Remember to put that arrow on the end. So Patrick could already have some amount of money that's either 25 or greater. And then when he gets $20 more, he'll have at least 45.